Hi, welcome. Today's lesson is inverse trig derivatives. So we're going to take the derivative by working through one of them, then showing the other important formulas and doing some examples. It should be a lot of fun. Well, some fun. Anyway, suppose y is the inverse sine of x, and we want to take its derivative. Here's the steps, but let's walk through them. If we want to take the derivative, that's a hard word to say really fast. We don't know the derivative yet, so we're going to apply sine to both sides. So the sine of y will be the sine of the inverse sine, which is x, most of the time. Well, within the domain that we're going to talk about, it is. Then I take the derivative of both sides. So if I take the derivative of x, I just get 1. If I take the derivative of the sine of y, well, y is not x, so this is not going to be like the derivative of the sine of x. It's a chain. It's the sine of another function. So the chain rule says it's the derivative of sine at the y times the derivative of y. Notice how this is really what we want because it gets us a y prime. And then I'm going to divide. So y prime is simply 1 over the cosine of y. But that's not a nice way to write it. We want it in terms of x. So we're going to use all sorts of fancy trig laws. The cosine of y in a nice range is the square root of 1 minus the sine squared of y. Actually, it's square root of cosine squared. Cosine squared is 1 minus sine squared. And then since the sine of y is x, that's 1 minus x squared there. The derivative of the inverse sine is 1 over the square root of 1 minus x squared. That's a messy formula and it doesn't have anything to obviously to do with trig. It's kind of weird. None of these formulas look like they have to do with trig. The derivative of the inverse sine is 1 over the square root of 1 minus x squared. The derivative of the inverse cosine is the same thing, but it's minus. And if you think about it, that makes sense. The derivation we had, when you take the derivative once, you'll get a minus sign, because the derivative of the cosine is minus the sine, not positive the sine. The inverse tangent's derivative is 1 over square root of 1 plus x squared. No square root anymore. And the derivative of the inverse secant is the 1 over this absolute value of x times the square root of x squared minus 1. Notice there are some patterns, there are some similarities, but there's a lot of differences. These are not things that you generally just intuitively understand, not at first. You have to get used to them, and most of the time, if you have to use them enough, you just remember them. So, but let's use them. Here are 3 problems. Try them out. I'll give you a couple seconds. Okay, hopefully you were able to work them through. The derivative of e to the inverse cosine of x. Well, this is a chain rule. We learned the chain rule. The derivative of e to the something is e to that something. But then we don't stop there, because we then multiply by the derivative of the something. In this case, that something is inverse cosine, and its derivative is minus 1 over the square root of 1 minus x squared. There's no way to combine these. Well, there sort of is. We'll look at that and we'll compare it to if I bring this up. Minus e to the inverse cosine of x over square root of 1 minus x squared. Honestly, I'm not really sure that's any prettier than this one. They're both just messy. They have a lot of unpleasant things that don't kind of work well together. So to say it's simplified, that's as simple as we're going to get. I don't know if that's really simple. Anyway, let's move on. The inverse sine of x squared. Again, this is a chain. There's a reason that we're doing this at around the same time we learned the chain rule, because it applies well to those. So, the inverse sine of x squared. Well, this is the chain. The chain says take the derivative of the outside, apply the inside, and then take the derivative of the inside. So it's 1 over the square root of 1 minus. Now you might be saying it's 1 minus x squared. But no, this is a chain. It's 1 minus what's ever in here. X squared gets squared. Why? Because that's the thing inside. This is a chain rule. It's this function and this is the inside function. So it goes inside for the derivative of the outside's result. Times the derivative of the inside. And this one will work a little better. We get 2x over square root of 1 minus x to the 4th. Hopefully that sort of makes sense. Hopefully the top one does make sense, and the second one you're going like, okay, I kind of get that. Let's try one more and see how it works. We have x times the inverse tangent of x. So there's really a times here. This is a product rule. So it's the derivative of the first times the second plus the derivative of the second The inverse tangent has its own special rule, 1 over 1 plus x squared times the first. So let me rewrite that a little bit. It'll be the inverse tangent of x plus x over 1 plus x squared. I would not bother to combine these two into one fraction because honestly it won't look any better than it does now. That's how you do it. They're messy derivatives, but they're not that terrible. There are 6, I only gave you 4 because honestly the other 2 aren't used at all. Until next time, this is Dr. Jet.